Okay, good morning, good afternoon, and good evening, depending on when you're listening to this slide presentation for the Cisco CyberOps. That is the Cisco Cybersecurity Operations Associate. At times, we refer this to as a foundational course, your first level course in cybersecurity, that puts you at an entry level job for a SOC Tier 1 analyst. So, we've laid some foundations. It's a 28 module series, module 1 up to module 28. So we've done module 1 up to 11, and this is the 12th module in the series. And the previous 4-5 modules, we've laid the foundation for networking. Now I want to talk about network security infrastructure. So how do we secure our networks? How do we plan the network? How do we lay it out? Now, this module has to do with you getting to understand your network as it concerns security. Explain how network designs influence the flow of traffic through the network. How you design your network is going to tell whether how easy it will be for an attacker to attack your network. How specialized devices are used to enhance network security. How network services enhance network security. Topologies. Earlier on, I was talking about, in the previous module, I was talking about the components of your network. So your networks are end devices, intermediary devices, network media. Throughout this series, you see me repeating some things or laying the foundations before they are now needed, is to help you so that, because once you hear something 2-3 times, you tend to internalize and become good at it. So I've mentioned this thing earlier on. You've seen it again, so you're going to know it better. End devices, desktop computers, laptops, printers, anything that is going to receive data, IP, whatever, from these guys or through these guys, you call them end devices. Any guy that is going to serve as a bridge, right? You call them intermediary devices. Anything that is going to act as a means of communication, right? Or through which communication is going to be done, like your wireless, Bluetooth, your LAN, all of those cables, and of course your wireless media, you call them network media. Topology diagrams. So this is your physical topology and this is your logical topology. So in your workplace, one thing you want to do is that you want to have a topology. You want to plan and lay out your network so that you better understand your network. If you see here, you're going to be seeing server room 2158, rack 1, shell 2, rack 1, shell 1. So this gives you physical view of how this network is laid out. Whereas on this logical topology, we're just concerned about the nomenclatures, the routers, the name of the routers, at what port is it connected to, and the rest. So you have different types of network: the small home, the SOHO, the medium and large, and the worldwide, which is the biggest of all, the networks of all networks. This is what a wireless LAN looks like. So you have LANs connected through wireless. You call that WLAN. The difference between a LAN and a WAN. So a LAN connects end devices within a limited area, like what you have here, whereas a WAN connects two LANs together, of course, through a router. So just note that anytime you introduce a router on a network, most of the times you're going to have a WAN. Now, this is what we call the three-layer network design model. Most of the jobs you're going to be doing, depending on what level of networking your knowledge is about, or you're providing security, is going to be at the access layer, right? Distribution layers is where you start having your ISPs and of course your core layer, because they now invest in infrastructure to help you connect to the internet. But most of your PCs are going to sit at this layer through the access layer. So you have your routers, they will assist you to connect to, of course, outside network. Okay, so you have a short 2 minutes video on your CISCO LMS that explains the three-layer model in network design. So you can be designing a public and a private infrastructure architecture. So firewall design is primary, and you could decide to use a software firewall or a hardware firewall, demilitarized zone. So that guy that is going to help you interface to the internet, that's what you call the DMZ. Zone-based policy firewalls. So you want to have firewalls within your network. Like I said, you could decide to have a hardware firewall, which is more expensive, or you could go for, aside, if you run Windows, aside from a Windows firewall and the rest, you can decide to get a software-based firewall to help protect you. These are the things that you can do to help protect your network. Okay, security devices. So you have a 2 minutes video on your LMS that tells you about different ways you could protect your IT infrastructure, starting from firewalls, ensuring that you have port security, ensuring that you have email SSL proxy, ensuring that you have an intrusion detection system and also an intrusion prevention system, ensuring that you utilize threat intelligence. Like in the forensic course we ran, we said that one of the ways most of these tools and applications they are able to counter cyber threats is that they learn from signatures of these malwares, viruses, and the rest. And the only way you can do that is through threat intelligence research. So you want to check common vulnerabilities and exploits. You want to check known vulnerability, educational sites. I talked about the Cisco Talos, I talked about the SANS newsroom, and several others. They have this data. So you can use this data to better understand how this malware they operate and how to better see current trends and how you can adapt to secure your network. Let's talk about firewall. So what the firewall does is that it either accept or deny. Serves like what looks like an access control. These are the benefits, these are the limitations. You could read this up. If you have questions, please don't forget to ask on the mentorship group. Okay, so you have stateless and you have stateful. What the stateful would do is that they are more versatile, but one of their disadvantages is that they scan almost everything, and the how would I put it now? They give us good view of everything that's happening within our network, but they check everything, and because they check everything, they can slow network traffic a little bit. Whereas for stateless, they permit or deny traffic based on some kind of information, depending on what you've configured them to be. Okay, so you have application gateway firewall, a proxy kind of firewall. So most of the firewall control and filtering is done in the software. So even if you're using a software-based firewall or you're using a hardware-based firewall, even the hardware-based firewall, of course, have an OS. So you should consistently and from time to time update the signature database of that firewall so that it can stay very much up to date. So this is what Cisco devices that perform as firewalls, how they look like, and asking yourself, how do I configure all of this? Most device manufacturers operate a very open policy. They know you're going to buy it. So if you're going to buy it, so they provide a complete, not just user, but also the technical manual for these devices. So if you're asking yourself, okay, how am I going to configure this? Uh, it's just an open book stuff. For all of the functionalities of each of these firewalls, you're able to see that in documentation, which is readily available within their knowledge-based section of the website. So of course you still have manuals for firewalls, for switches, for routers, and for whatever. Most of those manuals are up to 2,000 pages. So very, very detailed. Okay, so the thing you need to understand the difference between IDS and IPS is even some antivirus softwares like ESET. I'm very much aware because I've used, I'm a fan of ESET antivirus, anti-malware suites, either the smart security or the Note 32. Especially for the smart security, it has an HIDS. So even my intrusion detection system, what it does is that it scans all of the guys that all of the traffic that comes within my network and sees, identifies malicious traffic. This guy is going to stop it, right, based on some rules. But you have various types. So it can be a HIDS, it can be a NIDS. So if it's a HIDS, it's a host-based intrusion detection system. If it's an NIDS, it's a network-based intrusion detection system. So this operates as your end network. So if you have this, like the smart, it's set smart security I'm talking about, that is an anti-malware antivirus suite, but also has configuration for you to configure a HIDS. It's just going to protect that particular PC. Whereas for an NIDS, you install it on a server or on a PC and configure your network on it. It checks for intrusion on your entire network, right? So these are the advantages and disadvantages if you're going to be using either an IDS or an IPS. So for IDS, no impact on the network, latency, no jitters, no lags. But for an IDS, response action cannot stop or trigger packets. This is the best, more expensive, but it can impact your network traffic. So you want to make sure that you're dealing and you're having large bandwidth to be able to monitor all of the flow of traffic, because you could have some impact, right? So this guy can stop or trigger packets, can also use stream normalization techniques. So it could do some correction. That's why it's called preventive, whereas this guy just detects. Okay. Okay. I think I just mentioned this a while ago. So you have your host based and your network based. So this is how you lay it out. So Cisco have some specialized security appliances. They're quite pricey, but they serve their purposes. So you have the AMP, the WSA, and the ESA. For the purpose of your exam, you want to be able to understand that for the AMP is for malware, for the WSA is for web application security, for scanning and the rest, whereas the ESA is for emails. Security services. So please, there's an elaborate 7 minutes video on the Cisco LMS. I will implore you to read up to see how and learn more about these security services. Okay, access control is very important. So what do you do in access control? You want to control inbound, outbound traffic with respect to either port, IP address, MAC address, and other characteristics. So in access control, you're asking yourself, who should have access to this particular device, or who should have access to this particular network? Based on MAC address, port number, and MAC address, port number, and IP address. So there are two types actually, which is beyond the scope of this training. Okay, I think it's here even. You have standard ACL and extended ACL. So the standard ACL is just based on the IP version 4 address. So we limit, we permit or deny based on this. But for extended, all of this. So you could configure the switch. You could configure the switch, the ports within your switch,
and say, I want this to happen, I want this to happen, I want this to happen, I want this to happen. I don't want to allow some type of protocol, HTTP, SMTP, whatever. You can say, I don't want you to be able to get to social IP address. And the good part of some of these things that look like they are complex, which they're very, very simple and basic, is that if you have a basic home router, it will offer you some basic access control list configuration. It will give you opportunity to be able to block people from accessing a particular website address, which is still an IP, an equivalent. It can also give you access to blocking some MAC address from accessing. So you say you have outbound and you have inbound. You are denying people from accessing a particular website like Facebook, YouTube. I used to have a friend, not used to, I think it's still a friend. So we got discussing one day where we were trying to implement softwares for a hospital. And he said he found that because as software developers, you need people to use your application, especially softwares that were created from scratch. You need people to use applications so that your applications can go into maturity. Because as people use them, they make complaints, they make suggestions, they give feedback. You then tend to make your software better. Then, of course, with time, your software can sell at a higher price. So he found that the hospital, most of the staff, they were not using the software. They were just busy, still going through their paper mode and the rest. He told them he was going to come for kind of an update on their network, blah, 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 and the rest. He came, blocked out Instagram. When he checked their history, he found out that they spent a lot of time on Instagram, on Facebook, and whatever. He blocked most of those websites on the router. So most routers will give you the opportunity to do access control. So that's what you call a standard ACL. But it's extended if you're trying to filter just more than IP version 4 addresses, right? When you're trying to also filter the port, the destination, and all of this. So there's a packet tracer lab that has to do with ACL demonstration. So simple network management protocol is a very critical and important protocol that helps manage our network. Without SNMP, there's little even other protocols can do. ARP will not be able to function, DHCP will not be able to function, and all major protocols. Is an application layer protocol that provides a message format for communication between managers and agents. It allows network administrators to perform the following: manage end devices such as servers, workstations, routers, switches. Helps you to plan for growth, right? So if you have an SNMP management software, it uses the SNMP protocol to do what? To get a holistic view of your entire network. NetFlow, so it's a Cisco technology. So you call this kind of technologies proprietary technologies. Technologies that are just uh, meant for and adapted by a particular company. So it gives you information like network and security monitoring, network planning, IP accounting. For instance, you want to know how many IP address that has been dispensed so that you can know how many persons connected to the network for billing purposes. Port mirroring is a feature that allows the switch to make duplicate copies of traffic passing through a switch and then sending out a port with a network monitor attached. A packet analyzer, a hardware or a software that can analyze all of the packets of traffic that flows through your network. Wireshark is a classical example of that we're able to do that. For this SNMP, for instance, SNMP management suite, you have SolarWind. You could check that out. They have a suite for network management. Of course, this is also Cisco stuff. It just locks all of this information, right? Most servers, even web servers, we have a log file. Your routers, they also have a log file. NTP. The question is, why NTP? Okay, so the question is, why is NTP a very important protocol? That's network time protocol. Have you wondered why, for instance, you have a web server and or you purchase a web server and after 1 year or depending on how well your billing is, you are told that your validity something 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 has expired. So the question is that where does it get its time? How does it count time? Without a protocol that synchronizes time, it will be difficult for those servers to keep time. For instance, your router you have, check your router configuration. You get to, no matter the router, it gets to where you need to sync or configure the time on your router and select your zone and also even select your network time. So this is stratum 2, stratum 3, stratum 3, stratum 2, stratum 1, stratum 0. So this is like the lead clock, right? Which is very, very authoritative. So other PCs, devices, routers pick their timing from that so that they can sync. That's why if you connect to a router can tell and identify that, okay, you connected to the router by so time, you spent 5 hours, you spent 10 minutes and whatever. Why? It can keep track of time. Okay. An AA server is for authentication, authorization, and accounting, right? Okay. Tactos and radios, VPN. So VPN is a very important concept. If you want to create a secured connection between 2 points, branch A, branch B, over the internet, one way to do that is to implement VPN. So, but you're going to need a VPN router at each point, right? You need a VPN router at each point. So Cisco, Netgear, TP-Link, most of these manufacturers, they have VPN routers. So all you need to do is to get a VPN router, get a VPN client. You follow the instruction in the router and you configure a secured connection between two offices. And of course, you should have good bandwidth for connection. Let's say you have a PC in branch A and you're in branch B. You have some files in branch A, or you want to be able to drop some files in a PC in branch B or wherever. You're able to use two VPN routers, configure that, and so that you can remotely connect to those branches. So in short, VPN connects two endpoints over a public network, which is the internet, to form a logical connection, which can be layered at 2 or layer 3. Okay, so that's all about the network security infrastructure. So we just considered what are those things that we need to put in place in order for us to create a secured network. So one, we looked at VPN. Secondly, we looked at VLAN. Thirdly, we looked at segmenting our network. Fourthly, we looked at devices like firewalls. Fifth, we looked at IPS and IDS and so much more. So those are those 5 principles you should take note of when you want to make sure that you have a secure network. So if you have a network, ways you can implement securities by making sure that you have anti-malware, IDS software or hardware, you segment your network, implement VLAN, and also uh, if you need to connect between two offices, make sure that you implement VPN. Thank you very much. This is going to be the conclusion of the network security infrastructure module 12 of the Cisco CyberOps training. Please, if you don't have access to the LMS, make sure you contact us. And don't forget to log into your Cisco LMS regularly. You typically have about 3 months validity once you have access to prepare and write your NetAcad exam. Thank you very much. See you in module 13.